Hello? Dr. Lo, can you hear I'm talking?
We can hear you, Miss Bhavani.
Okay, right. Thank you.
Bhavani, you're going to be the MC, right? Is it? Okay. Okay, good.
Can you hear me? Sorry. I can hear you just now, Bhavani, but I forgot to unmute.
We have got 6 more minutes, so we will start soon. Let me check the number of participants. We have about 20 participants, including our internal staff.
Bhavani, when we do the session on the afternoon Friday, is usually like this. Even during the RC, the participant will come in late.
Friday mood.
Yeah, Friday mood, holiday mood.
By the way, are you all in office?
Actually,
today?
Yes.
how did you choose the slot? How did you decide on having a 3 to 5 on Friday?
It's given to me because the week is very packed. So
Okay,
this is the
no other slot available.
Yeah, this is the best slot we can get. Hi, Dr. Wala.
So today's session will be by Dr. Wara and Ninja Sharafuddin, right?
No, just me. Only
Oh.
me for 2 hours.
Okay.
Just to support.
Thank you, Dr. Wara. Is there any echo?
No, it's okay.
Okay, good. I'm going to try to sharing. Can you give me some time to do the sharing, Bhavani?
You want to do now, is it?
Just want to test how to share the file. Okay.
Okay, sure, no problem.
Can you see the file, the slide? Bhavani, can you see the slide, Bhavani?
Just a
No.
moment. It
Not yet, it
shows
hasn't come in yet.
Sharafuddin is starting to share content, but it's a blank page. Maybe you should scroll. Scroll to the next page.
I already go to the next page.
No, I haven't loaded yet.
Yeah, I think it's still loading.
Do we have to now download it or just to use
Where are you sharing from?
sharing from Google Drive?
Oh, from Google Drive. Or Google
Get
Drive
idea?
will take time. Why don't you just download and then share?
Okay, better do that. Hold on a second.
No, because if you directly from there, it has to download and then come to our server, then our server have to download.
Yeah, better do that. Hold on, hold on.
Three PM now. Should we wait first or should we wait for Cikgu Din to? I can't see you. Or is my connection problem?
I think
Saya
just
pun tak nampak juga.
No, you can't see him.
Dia berpusing-pusing, loading.
Okay, hold on a second. Can you see me now? No, not yet.
No.
Let me let me leave the
Are
meeting
you
first.
connected with two devices, Cikgu
Yes,
Din?
yes,
I
two
see.
devices. So
Yeah, I
the
can see two names here.
Shafuddin 2 is my other devices. I'm going to leave the meetings. Hold on, and then going to still no picture of me.
We can hear you, Cikgu Din, but we cannot see your face. Am I right, the others?
Yeah. Oh, okay, now is that.
He
Okay.
is hiding behind the camera.
Okay, we
Okay,
can see you
start
now.
Okay.
Yeah,
good.
sure. Okay, right. A pleasant good afternoon, everyone. Dr. Wan Nur Azmin, our Deputy Director of Training Program and Research and Development Division. The speaker for today, Mr. Sharfuddin bin Abdul Shukur, and all the specialists, as well as all participants. Good day to all of you. I welcome you to the webinar series on Introduction to the Basic Computational Thinking Skills for Primary Science Teachers. So the first session was conducted on the 23rd of September already, last week, and today will be the continuation. So I would like to welcome all of you again to this beneficial event. And we hope that we will be able to share knowledge with each other. And we hope to hear your feedback later on. So before I introduce about Mr. Sharfuddin to you, allow me to explain to you about the evaluation session. So we encourage participation. Those who participated last week, we also encourage all of them to participate today. Upon this session over today, our ICT help desk will actually cross-check the attendance of both the days. And next week around Monday or Tuesday, we will give you the evaluation link personally sent to your registered email. We will require you to fill up the evaluation link. Upon successful submission, we then will give you the e-certificate. Okay, so I hope that is clear. So before I hand over to Mr. Sharfuddin, allow me to say just a few words about him as an introduction. Mr. Sharfuddin is a specialist from Training Program Division, okay, Senior Exam. He holds a master's degree in Education Management and Administration from University Technology Malaysia. He also has 20 years of teaching experience as a science teacher in Segamat Johor and Kerian Perak. So currently, as I told you before, he's attached to training program as a specialist, and he has been facilitating and supervising training courses for educators from SEMA member countries and beyond. Okay, with that, I hand over to you, Sheikh Goodin. So the floor is yours. The platform is yours.
Thank you, Miss Bhavani. All right. Before we start, I want to see all of you. I want to take a small pictures, all of you. Can everybody switch on their video? Yeah, there's one familiar faces, Zaitul. Oh, nice. I hope everybody can, as the session go on, can you, if possible, switch on your video, because when we as a teacher, when we teach, looking at the blank blank screen, it's like talking to yourself. So if you can show your face, at least I can see your reaction, and maybe from there the communication will get better. So I hope we can always switch on the camera. But if you cannot, if the connection is not so good, yeah, you can switch off your video. Is it okay? Okay, I can see everybody's here. Only Camille is not here from Philippines. Anybody from Philippines? Outside Malaysia, I mean. Christy, Christy is here. Hello, Christy. Okay. Let's start. The time is 3:07. Okay. I'm going to talk about the computational thinking. This is the second part of the webinar. The first part was conducted by Dr. Low, and I'm going to do the continuation here. So before we start, anybody would like to ask questions or to say hello? Anybody?
I believe Christy raised her hand.
Oh yeah, Christy. I only can read the chat. Okay, Christy, send us the chat. Okay, Zaitun and Christy are my alumni, and they're attending one of my RCs. Okay. For those who are new, my name is Shafrin Abdul Shukur. I'm a specialist in simulation. Okay. but currently I'm a seconded here for 2 years. All right. Um, before, if there's no question, I'm going to share to you my slide. Okay, so bright orange color, suitable for afternoon session. Okay, I didn't get the title properly, but I got the idea, which is computational thinking. And the subtitle here is integrating the computational thinking in the 5E lesson plan. There's a lot of a lesson plan, but we are accustomed to 5E lesson plan, which is more appropriate for science. So let's start. Okay, these are the slides from Dr. Low. I just want to get in touch with you from our last session. Okay, hi Siti from Penang. Okay, Dr. Low's introduced to you the computational thinking in science. Okay. She mentioned about the project-based learning and STEM practice. Okay, so first of all, I want all of you, the teachers, don't think as computational thinking as a new things to us. Actually, we as a teacher already done the problem solving skill using computational thinking, but we didn't name it as a computational thinking. We already practice using computational thinking. So don't think this as a more work to you. Okay, we already done the computational thinking, but my idea, my objective today is I want to show to you where does the computational thinking fit in our science education. Okay, so this is where is it. This fall under STEM practice, and it can also be used in a project-based learning. Okay, so for STEM practice is more like habits. Okay, the thinking process. Okay, where student build, test, and revise model and simulation. Okay, I want all of you to pay attention here. When we're going to implement the STEM, we're going to have some practices, and our today's discussion falls right here, computational thinking. When we do the STEM, when we actually do the STEM in our classroom, we're going to apply the problem solving in the STEM practice, and this problem solving is called computational thinking. Okay, so I want you to get the idea, where does the computational thinking fit in our classroom. So to put in the one sentence, computational thinking is a way of solving problem in a very in a very systematic way, and we can use it in the STEM practices. Okay, so the short word here is computational thinking is a problem solving technique. Okay, this is the slide from Dr. Low. So engage, explore, explain, extend, and evaluation is 5E lesson plan. So I want you to, for evaluation, Dr. Low put it under here because evaluation can be done along the lesson plan. Okay, sometimes we put evaluation at the last, as a last phase here, but actually evaluation can be done along the way. Okay, and this is what the engage are, and try to, we're going to use the computational thinking over here. Okay, we try to use it under the explore phase and explain phase. This is very interesting because these are, in my opinion, these are the main phases in 5E lesson plan. So I hope by introducing computational thinking idea in your lesson plan, it will help students understand more, right? Okay. Okay, these are the today's learning objectives. First, there are just two objectives here. First, we're going to apply the computational thinking concept. So we're going to, how we going to use the concept? What's the relationship between computational thinking concept with STEM? So I already give you some ideas there. The relationship between CT and STEM. And most of our session today will be integrating the city elements in the 5-year lesson plan. So like I said just now, we're going to use it during the, only for the two phases. Okay. The phases are explore and explain. But I'm not going to limit those city under these two phases. Maybe some of you have some idea how to use it in the other phases. Okay, so as we go along, try to think of a possible way to use cities on other phases. Okay, feel free to ask question. Well, okay, you can ask question. You can interrupt me. I don't mind. Okay. Okay. This is a Venn diagram about STEM. So for STEM comprises three thinking areas, which are design thinking, system thinking, and computational thinking. So in today's lesson, we're going to go deeper here. Computational thinking in the STEM thinking session. Okay, so like I said before, CT is the problem solving part in the STEM practices. Okay, so there's a lot of in STEM practices we have three thinking skill, and one of them is computational thinking. So I hope you get the idea here. Any questions? Okay, let me go forward. Okay, I assume you already familiar with these elements. Okay, we in computational thinking, we have four key concepts. We have decomposition, we have pattern recognition, extraction, and algorithm. So Dr. Low have go details on this. So we're going to move forward. And somehow, there's a step in using the computational thinking. Okay. When we try to do the activities in the classroom, we can use these steps. It helps. First, we can specify the problem using 3 out of 4 of the key elements in computational thinking. First, we can use the extraction. In extraction, we're going to remove aspects of the problem that are not needed to the, does not contribute to the solution. Okay. And then we're going to chunk the problem into a smaller. Okay, from a big problem, you're going to make it smaller, easier for us to solve the issues. And somehow, if we make it smaller, it's more manageable. And while doing this, hopefully the child, the students, can see the pattern. Okay, in this case, when we do the density in our activities, they can see the pattern, which what type of object that can float, and what type of object that sink. Okay, so they hopefully they can see the pattern. And for number 2, algorithmic expression is more like how to do the activities in a very uh, step-by-step instruction, in very formal way, in a very standardized way. Okay, so how to do the activities in a more proper way, where when we do this step by step, somebody else, when they try to do this activity, they can mimic our activity, they can follow the step by step instruction. So that's algorithmic expression. And for number 3 is the solution, implementation and evaluation. We try to extend a solution for a particular problem to the other problems. Or when we teach students about the one concept, how they can apply the concept to the real world. So these are the steps to computational thinking. Okay. Any questions? Okay. Hope no questions. Okay, where does computational thinking this is a Venn diagram. It's a very nice Venn diagram. I want to make sure that we are not confused with computer science. So I want to give you like 10 seconds to look at this Venn diagram. And so when we say about the computational thinking, the way we solve the problem, it's not actually a computer science. Okay? Although we use some of the fundamentals in computer science as a way for us to solve our everyday problems. So we use the discipline or technique in computer science and try to use it to solve our everyday life problems. So in this case, try to solve our science activities problem. So a part of computational thinking is actually computer science itself, and within the computational science, there's a small part here which is coding. So when we try to, when the MOEs introduce the computational thinking to the teachers, they are reluctant to give their reluctant to follow the initiative because they're afraid they have to learn coding. Okay, actually coding is just a small part of the computational thinking. Okay, so like I said before, we already apply computational thinking in our everyday life, but we never said it as a computational thinking. Okay, we did solve our problems systematically. So that's the idea here. Okay. Anybody want to add? So anyone who do some reflections, maybe I thought computer thinking is like this and like that. Anybody want to share? Don't be shy. Christine, you want to say something? Yes, go ahead. Zaitun, want to share?
Okay, good evening. I want to just share. I think we already indirectly applied the computational thinking in our life routine. For example, we as a teacher, I think we also apply when we prepare for our lesson plan, for our work. So I
Yes.
think it's in daily routine, so it's indirectly applied.
Yes, you're right, Zaitul. We already done this, but we never say this. I'm going to do a computational thinking right now. We never say that. We already done it, but we didn't realize that we are using the computational thinking. Good. Good.
Sir.
Yes. You see, Christy?
Yes, sir. Yes.
So now I can hear your voice. Okay.
Actually, sir, looking at the lesson plan that you have shared to us last uh, September 23, you have shared to us the documents and the sample lesson plans. And as I look at it, sir, we are already doing this in our
Yes.
school, yeah, in our practice, but we are not naming it as a computational skill actually. And so since no, the first time that I hear about computational thinking skill, I think about computer programming or mathematical skills or the process in mathematics or in doing the ICT. But looking at the lesson plans and the activities that you have uh, give to us, uh, I said, yes, to myself, I am already doing this and applying this. But the word or the term computational skills is already new, is a new one to us. But we know that we are already doing this. Yeah.
By the way, how's your webinar the other day?
Yeah.
Your multi
Yes, sir. I have a lot of webinars actually.
the one that you asked me to join. You remember?
Yeah, sir. Yeah, and aside from that, I also have from the secondary. I'm also doing webinar for the secondary teachers in science. So
Oh.
my multiplier effect had been in the 10th series.
Oh my God! You have to send me
Yeah,
the report then.
yeah. Actually, it's already on. The 11 series is ongoing right now. I have for the secondary teachers. My test is already applicable not only for the primary grades but for the secondary science teachers. Thanks to you, sir.
So does Deva helps a lot on Telegram?
Yeah, sir. Yeah. They
Okay,
are
good,
very
good.
interested with the one that the one that you introduced to us. They're very interested, and here in our province in the Philippines, we are already some of the teachers or those teachers that I attended my training, my webinar, have already doing the applying those skills and those things that you have taught to us during our course. Thanks to
Great to
you.
hear that. Okay,
Yes,
thank
sir.
you. Okay, before I move to the next slide, so I'm going to read this to you. CT is a way of solving problem, designing system, and understanding human behavior. And all these are copied from the computer science concept. Okay, that's why it's called computational thinking.
Mr. Shafuddin,
Yes, yes.
yeah, can I share something? Yeah,
Sure,
just now, Christy and Cikgu Zulaika, Zaito, sorry, Cikgu Zaito share about, sorry, Cikgu Zaito and Christy share about that the computational thinking skills are something that when we learn about it, we realize that yes, we are doing it in our everyday life, which is correct. But I think as teachers, including myself, knowing that we are applying this in our everyday life, so what is important for us as teachers are how we can actually intentionally and also systematically use this in our teaching and learning. Yeah, especially for our students. Yes, they are using it, but I think the role as teachers are how we can actually intentionally train our students and ourselves to use these skills. Yeah, this is from me. Yeah, thanks.
Okay, good. Thank you, Dr. Long. Yeah, but we need to somehow instill this idea to our students and tell them that it's not like computer science per se. It's more like how to use this computer thinking as a way to solve our everyday issues. Okay, good. And as a teachers, we need to find a way to to introduce this concept to our students, which is what we're going to do today. Okay, how to introduce the computational thinking in our lesson. Okay, this is the 5 E's. Again, we're going to focus on explore and explain. Okay, I hope everybody has their materials in their hands right now. We're going to do some activities on density. Okay, and we're going to first. I'm going to show you the syllabus. Here we call it DSKP, and from the DSKP, the lesson. It's more like a syllabus, okay? In Malaysian standard, it's a syllabus for science, primary science, and from there, how we going to apply those syllabus in our lesson plan. Okay. Come on. Okay, this lesson, this is a 7.0 lesson called density. Density is introduced in year 3, falls under physical science. Okay, this I'm sorry, Christy is in Malay. Okay, this is the content. This is the 7.0 density. So we going to the standard here the primary teachers, they have to follow this standard. For the content standard 7.1, they must show this is the this is the English part, more or less. Okay, teachers have to the standard content here is somehow teachers have to show object or material that is denser or less dense than water. Okay, so they have to show which object is denser than water, which object is less dense than water. So here we focus on water. Okay, so the standard here is there are 4 standards here. First, they have to make inference about object or materials that rise and object that sink. They can make an inference by doing the activities, which we're going to ask them to do in the classroom. Okay, because these are simple activities, they can do it in the classroom. And for when we do these activities, I want you as the teachers in this session today, try to think of what kind of computational thinking elements that we can instill in these activities. Of course, you can. What are the best CT elements that we can highlight in this activity? Okay, this is wrong translation. We're going to connect which object that arises and which object that sank. You're going to connect the phenomena of rises and then and sinking with the term density. This is very difficult because this is year 3 student. We're going to introduce them the term density. So again, which part of the conventional thinking that are most appropriate to introduce the term density here? So we're going to do some brainstorming right after this, but I'm going to give you we're going to be the student first. We're going to do the activities, and as if we don't know which object will fall, will sink, which object will rise. So from there, I hope we have some thinking on how to introduce the concept of density, and maybe take advantage of computational thinking to introduce the word density here. And we're going to have the third activity here is over here is we're going to solve the problem of making the water more dense. Okay, we're going to find a way to make the water dense. So we're going to in the lab we can give the students materials, and they have to try to make the water denser. Okay, And for 7.1.4, we're not going to go through here, okay, because it's more like explaining the observation. Okay, maybe we have more time, we can go through here. Okay, but for today, maybe we're going to do 7.1.1 until 7.1.3. Any questions before we start? Okay, this is the standard content. Okay, Christy said it's on the 4th grade. So in Malaysia, we introduced it in the year 3. Okay, these are the learning standard. Again, all the okay, this is on. Okay, can we start now? I'm going to stop sharing first. Okay. For those who have the material at hand, can you try to do the simple activities for 7.1.1 until 7.3 and get the feeling of what really happens when the student do these activities, and try to I'm going to share to you the Jamboard right after this, and you're going to write down your ideas on the Jamboard. Okay. Okay. Let me share the Jamboard first. Anybody want to add or want to comment? Anybody want to comment? Okay, right now I'm going to post the link on the chat box here. Okay. So I already post the link on the Jamboard. All you have to do is use the sticky notes and go to the appropriate page. For example, for activity 7.1.1, you find out this, use the sticky notes and don't forget to write down your name and just fill up the Jamboard with your ideas. Okay. In the meantime, I'm going to show you my activities. Okay, let's look at this video carefully. I hope this run well. There's no voice in it, just a picture only. Hold on a second, it's not running. Hold on. Okay. Okay, these are the 7.1.1. It's about how to distinguish between floating and sinking material. So this is a very simple activity. So I'm taking the straw. Okay, materials that we can find easily around us. So you can in the Jamboard, you can write down any comments, any suggestion. Maybe I do it wrong. Okay, what should I do to make this lesson more meaningful to the students? Just keep in mind how to apply the computational thinking in these simple activities. Of course, when you in the classroom, you always ask the student to have a checklist or something. Maybe you can add here. So we can share ideas. Maybe we can ask the students what are the criteria that make the object sing, for example. Okay, they can list down the materials. Okay, that's 7.1.1. Any questions before I move on to the next video? In the meantime, you can do this on your own, or you can have write down on the Jamboard that I shared to you. Any questions? All of you are so quiet. Any questions?
No, no.
Deva, you understand what I'm trying to do?
Yeah, I just want, yes,
yeah.
very simple, but then it's very interesting. Just want to share something. If we use our food type of materials in classroom, there will be more interesting, my opinion. For example,
Oh.
you say like lemon, orange, even egg, rotten egg and a good egg. You know, it looks funny, but that's where we can attract them, I guess.
Yeah, then we can come up with a question: why the rotten eggs?
Yeah, things you can start to ask things then.
Yeah, good idea.
Just
As opposed
share.
of as opposed of using different materials, random materials,
Yeah.
why don't we use water to differentiate between good and bad object,
Yes.
for example?
When
Okay,
we
good.
use food really attracts students.
But again, they're going to eat it.
Yeah, exactly. That's what I do in my classroom. They will eat it, even though in the lab.
Okay,
A
good
simple
idea.
one.
Good idea. Yeah, because when I'm preparing this, I said so boring. You don't just ask the students to put some object in
Yes,
the
yes,
water.
yes. Maybe
Okay.
this one might be a good one for the good students. But if you look at the naughty students, very active, naughty active students, they prefer this type of challenging type of materials.
So you have a lot of time teaching the
Yeah, I
nasty.
always teach the last class students. I have a lot of experience with them. To
Okay,
pull their
good.
attraction is like that is our biggest challenge.
Okay, thank you, Deva. So
Thank you.
again, thank you for the idea. So again, try to do this under the context of computational thinking and just write down on the Jamboard that I shared to you. Okay. All right. Next. Let's go to the next one. This is the 7.1 point. Okay, we already done this. This is 7.1.3. How the idea here is how to make the water denser. So first we need to show them in the plain water on the right hand side here. On the plain water, this is not grape, this is a tomato cherry. It will sink. So the question here is how to make the tomato cherry float. So before this, on the 7.1.2, we need to instill the idea that things that float, object float because water is denser than the object. So this is what we're trying to do. We're going to how to put this idea that when the when the object float, indirectly we can say that the water is denser than the object. Okay, and if the object sink, indirectly we can say that water is denser than the object, or vice versa. So these are the ideas that I think the DSKP, the lesson, the syllabus try to 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 instill in the students' mind. Okay, how to make the water denser, or how to make a sink object float. Hold on, let me get this right. Let me share the file here. Okay, this is the file. And the second cup is the cup with a salt in it. If there's an error in my activities, you can highlight in the Jamboard. Okay, we're going to share ideas. Maybe in this case, the water quantity is not equal. Student will say that, oh, tomato cherries float in a more in a place where there's a lot of water, for example. So if you can see that, okay, the first activity here is sink. So how to put the city computational thinking in this context? How are we going to instill one of the elements in city in our activities? Okay, look this again. I'm sorry, the water level is not the quantity should be the same here. Okay, we want to make our experiment as fair as possible. So feel free to fill up the Jamboard, okay? And I want to see your idea, okay? All right. Any questions? Feel free to ask if you want to ask anything. Okay. Okay, these are the third, I call this video project orange float because it falls under the project. Let me go back. Okay, there's a project suggestion here. Okay, one of the suggestion is how to see the difference between oranges. Okay, what's the density of an orange with the skin and without the skin? So see the difference density of orange with skin and without skin. So this is a project. I don't know why it's called project because it's a very simple activity. And I did suggest that we prepare a bubble wrap, sorry, a bubble wrap to so maybe we can introduce to the student a few materials that can be the orange skin. Okay, maybe a paper or some a lot of things that can be the skin for the oranges, and we see what happen if we use different material for the orange skin. Okay, okay, let's see the video. Oh, okay. So when we introduce the project here, okay, this is uh, the the video. Hold on, need to change this. I need to get the video first. Where are you?
Mr. Sharfuddin,
Yes.
I just want to share. Density is one of my favorite topics in Form 1. So,
Okay.
what I would usually do in my class is for them to have a number of teh si ping.
I'm sorry.
Teh si ping. You know teh si ping? It's a 3-layered beverage.
Oh, okay. Yeah. Okay.
Yeah, I will ask my students to bring a few things, and then we will have each group have their own teh si ping. Of course, they can't drink that teh si ping, but they can explore that teh si ping. So teh si ping is actually a 3-layered beverage idea from Sarawak. The bottom layer is sugar, the second layer is condensed milk, and the third layer is tea. So my students will bring coffee and Milo and all that, and they will be making their own teh sipping or Milo sipping or whatever lah. Yeah, just wanted to share. And then the second thing is how my favorite question will be, why does the rock sink and the Titanic ship float?
Yes.
That will start off their computational thinking. So something as huge as a ship can float, and something as small as a stone can sink.
But remember, Dr. Nelson, we cannot introduce the formula.
Yeah, we can.
Rho
This is
equal,
one.
yeah.
This
So
is
this
form
is
one.
very deep. Yeah, this is very
Yeah.
difficult to.
Yeah.
So
We don't introduce, but we can elicit the ideas. So
yes.
because they're observing, like they go to the seaside and they throw a stone, it sinks. But when they see ships, it floats. So how do you do that? Why is it? Yeah.
So I think the orange float is the good example for us to show that sometimes a bigger object can float.
Yes.
So we're going to show them when we use the bubble wrap, it become bigger, but
Yeah.
it float compared to the orange without the skinless orange will sink. So we're going to use the computational thinking. Yeah, this is where you're going to put your idea in the Jamboard. So
Yeah.
okay, thank you, Dr. Nelson.
Thank you very much.
I'm going to show you the video.
Yeah, Mr. Shafrin.
Yes.
Just another idea that we can, impart lah. Impart. No, just now you showed the tomatoes, tomatoes, right? Tomatoes, it floats in pure water, and it sinks in pure water and floats in salt water, right? Okay, so that's one part of it, right? Now let's say we have 2 glasses of pure water, right? So we could ask them, okay, now both are pure water, and you have the same two tomatoes, all right? Now, if we put both, if we insert the tomatoes into both this cups of water, it will sink, all right? So now, what can we do? We can throw a challenge at them. Okay, what can we do? What can we do in order to make one float and the other one sink?
Okay, that's where that's where we can instill the computational thinking process in their okay.
So you see, so now, of course, they will do things. Okay, water they don't change. All right. So what changes can they do to the tomatoes so that one will float and the other will keep sinking?
So what you're saying, Dr. Tiru, is we're going to put up front in the classroom a few materials that they can use in the water to make the water more denser than the tomato. Is it? So ask them to choose which object is that what you have in mind?
No, we don't change the texture of the water. We don't change the nature of the water, nature of the object. We change the nature of the object.
Okay, one way of thinking. So
all right. Okay. So this one we can link it to our daily life. All right. We can link it to our daily life. You see, of course, when we go to the seaside, we take the children to the seaside or the the swimming pool for swimming, all right? Okay, or when more commonly the seaside club, all right? So now, if let's say when they go into the sea, when the children go into the sea without a float, what happens? And when they go into the sea with a float, or I mean with a life jacket on, or a float on, okay, what happens? Okay, why the difference? You get what I mean?
Okay, yeah.
So these are things that when we teach this concept, we must relate it to a concept in real life. We can relate this concept in real life. Can you see the link to that?
So what you're saying here, when we introduce them the concept, we can always go back to the real life experience.
Yes. Because I mean, of course, what we see in what we experience in real life is actually part of the things that we learn in school like this. You see, all right. Now, okay. Now we will look at the tomato. All right. Okay, water. The nature is the same. All right. Both are pure water. All right. Initially, when we put one tomato into the water, it sinks, and then we put the second one into the second cup of water, it also sinks. All right. Okay. Now we must throw a challenge to them. All right. You can make changes to one particular tomato and make it float. Okay, what can we do?
Okay, good idea, Dr. Tiru. Can I suggest a few things? We can do this both way. One way we do something to the water, or the second way is we do something to the tomato.
Yeah.
Maybe we grab the tomato with air bubble, or we put salt or sugar in the water. So we can go both ways.
Both ways. But you see, of course, when we are doing this activity with children, so adding salt to water to make it denser is something very abstract to them. But on the other hand, now like just now you said you wrap the tomato with bubble wrap. Bubble wrap is something concrete. They can see what's happening. But if you just add salt in the end, both look the same. They actually, when we talk about children, children of primary level, they are still concrete operational, we call it. They see it, they know it. They see it, they realize it. So when we talk about when we add water, salt to water, and it becomes denser, and we want them to realize that one, they have to be more abstract, uh, operational. They must be able to see these things. Okay, so this one will happen when they come to secondary schools. But while in primary school, I mean, while in lower primary, I would say lower primary, they are still concrete operational. They want to see something happening, then only they will make a link to it to the things that they are learning. But as long as, if you, let's say you add color, yes, they see.
They can see the color.
Yeah, if when they see, when you, let's say okay, now we have okay, sweet, a sweetened liquid with color, red color or something. So we add this one, all right, add this one. So they are able to see it. Okay, pure water, they are adding something to it. Okay, something like sweet and all that. So that will make it dense. They know that. But if we are talking about when we are talking about just pure water, both are pure, colorless, they won't be able to see, they won't be able to picture it clearly.
Okay, Dr.
Okay,
Thiru.
I mean, of course, your idea is definitely applicable. It's good for children of higher, higher standards.
Okay, since you said about the concrete part, maybe somehow
Concrete
we can
operation.
ask that, yeah, maybe we student cannot see the solution, the salt in the water, right? But we can always weigh the solution, see the difference. When put salt in the solution, the mass will increase. Is it possible to make the students see that there's the differences between those two water? Is
Yes,
it possible?
yes,
Yeah,
but
maybe.
you must understand one thing. You see, as children, as children, okay, when we, of course, we know very well when we add salt to water, the weight will increase. Okay, but the volume will not increase. We know.
But for student, it's
For
difficult to
children,
children.
of lower standards, okay, it is not so hard. I mean, not so easy to find
Yeah.
children who will be able to note the difference.
Okay.
Maybe I do not know because I've lost touch with small children. My children are all very big now, so I have lost touch of small children. Maybe the teachers in the group, okay, they
Yeah,
might
maybe
be
the
able
teachers.
to give us the feedback. You can, maybe they can, I mean, the teachers in the group, they can chip in whether to see whether, okay, the ideas or the suggestions made is actually can be appreciated by young children. They will know because of course, children of these days are not like when we were children. See, of course, nowadays children are more alert, more receptive. Okay, they have more exposure, right? So maybe the teachers in the group, they can give feedback on that.
Okay, anybody?
So
Anybody from teachers from this group? Anybody want to share ideas while I'm playing this video? Anybody want to share ideas?
maybe in sharply you can just we have the list of names there. Just call. Just they may be shy. So just call one of them and say, oh, what's the idea? They're very shy to open up. We have a
Who's the
number of
lucky
people on the
one?
list.
Okay, let me stop sharing first. Ah, maybe Esperanza are you there? Esperanza? Maybe Magiswari? Is Magiswari there? No? Anybody else want to share?
Maybe one
Hello,
Zaitul there.
Doctor.
Zaitul.
Yes. Yes.
Maheshwari is there. Okay.
Doctor.
No, Cikgu
What?
Syarfuddin.
Okay. Cikgu, Cikgu, kali ni I ajar murid tahun 4. Last year, I used to teach this density topic to my students.
Okay.
Okay, before I go to use the thing, I ajar dia nak tunjuk density water first. So I use different liquid first, like oil, and then air syrup, then water. So tunjuk dia water density tu dulu.
Okay. Yeah, Mageshwari.
Yes.
I would like to just get some clarification from you. All right. Now, okay, you use different material to show that they are of different density, right?
Yes.
Is that right?
Because
Okay.
for the
Oil.
primary student,
Yeah.
density tu kita perlu jelaskan dulu. We have to clarify the density first. So
Are they
we say
able to?
density. Then they will ask density itu apa? So we have to clarify the density first.
Okay. How do you clarify density to them?
So
What do you tell them to make them understand about density?
So I use the different liquid to show the why we can we use the water. So that we can show the okay. Let's say I tuang oil, then water, then the syrup. The water and then the different level of the liquid level. So we can say not only water we use for liquid density, the other things also we have.
Yeah, that's a very good thing. Now I see. Yeah. So what she's trying to say is, okay, we use different liquids. We compare different liquids and we compare the densities of different liquids by showing the layers. Is it? Okay. Like
Yes, yes.
water
So
will sink and oil will float. Is that right?
yes, and
Okay.
then I use the different level colored the color liquid, and then
Yeah.
I will put the thing that like tomato or whatever the things. Then I show the level of the density there.
Okay.
But
Right.
I'm sorry, Magaswari, but we somehow in the DSKP, out of the blue, we need to teach them density.
Yes, because
So it's very difficult.
no, actually we are using the water, but we still connect to the other liquid because they are giving the project, right, the project. So we have to connect that to the our DSKP because we are doing project. So let the people clarify with the density first, then only we carry out other activities. So
So you
see,
so
so first I will use water, then I will put oil, then we'll put the water, the syrup, like you do, right, sir? You do the salt solution. Okay, the salt solution and the water and the liquid will show the differences.
so what do you say what happened when the oil float and the water sinks? So what do you say about it to the
Okay,
children?
so we will ask the student why you can see different layer. So
So
people
that's
will
what
say, the syrup contains sugar, the color, and then the water is nothing, zero. Then oil will add the composition. So they will come out with their ideas. So this will make the difference of the density. Then we will put the, okay, let's say grapes or different the nuts. The nut will go down. compare with the grape. So grape will stay after water. The grape will stay. It won't go down to the oil, but the nut will go down to the oil. So it will show the difference between the other things at different density. Different material,
So,
different liquid with have different density.
so straight away using the water, using the liquid as an example, straight away you show them which one is denser, which one is less dense.
Yes.
Get the so to
Yes,
make sure they get the idea.
and then we will see the sinking and floating also over there.
All right.
Okay,
Okay, thank you.
Thank you.
Anybody else want to share?
Pan Mangeshwari, I want to ask you just one more question.
Yes.
Okay, now you said you are teaching year three to children, right?
Yes.
Okay. Now for year three, they already know the word density.
Year three, they already repeat your question, sir.
So do you already teach them the term or the concept, the density concept to them already?
Yeah, year three we have density.
Okay, right.
Yeah.
That means
So
they learn it quite early. That means Okay.
Yes, sir. Yes.
All right.
okay, allow me to share this. These are the project where we're going to use the bubble wrap to make the skinless orange float. Okay, I want to show you this video. Oh, I can play it well here. So somehow, I we as a teacher, when we do some instruction to the students, we ask them to wrap the sphere oranges, right? I'll do some research. There's a lot of way to wrap a sphere object. So maybe this going to be the one of the algorithms or in the computational thinking, how to wrap a spherical object. So if you have a time, you can always Google, and there's an origami, a kind of origami on how to wrap a sphere object. Yeah, okay. Okay, I'm using the one of the method here. We just simple wrapping here. Okay, there's a triangle wrapping and a lot of type of wrapping. So maybe we can use this kind of activities as one of the point in the computational thinking. What are the steps we need to do to wrap a sphere object, for example? Okay. So we try to make our activities as scientifically as possible because we want to instill the computational thinking in our lesson. Okay. Yeah, it also can serve as an evaluation, formative assessment in our classroom. Okay, see how the student do their work. Anybody want to add here? Okay, that's it. We already wrap our oranges. Now we're going to make our oranges float. So I like to give throw some suggestion here. Instead of using bubble wraps, we can always ask the students to come up with other materials that can replacing the bubble wrap. Okay, so it can be a new challenge for them. Okay. Anybody have tried this in their science classroom? Anybody want to share? Anybody? It's a very simple activity. No? Okay. Okay, allow me to look at the Jamboard. Okay, we already done with the density part. Before we move on to the magnet part, let's see what are your where is the Jamboard? Okay, good. Okay, I hope everybody can see the Jamboard here. It's so small, huh? I have to make it bigger. It's not big enough. Oh, goodness. Okay, this is mine. Okay, we have one participant who say that he or she give the picture here. Timbul. Okay. So this is a pattern recognition, falls under pattern recognition. Objects such as metal pin, plastic cube, nail, sink in water. Objects such as foam, sponge, straw, float in water. Okay, anybody want to add here? What are the patterns here? Anybody want to share with me? What can we say about pattern recognition here? Can you see the pattern? Anybody?
Can I say something?
Sure, sure.
Okay. So here the pattern we have to stress to the kids are object that more less and less dense than water. So we have to stress them the word dense. So if
Mm,
the object less dense than water, it will float, and then if more dense than water, it will sink. So
so
the pattern is there.
are you going to write a simple formula? Less dense than water equal to float. More dense than water equal to sink. Are you going to do that kind of a simple formula?
Yeah, for primary, we will stress this. Maybe upper level, they will go more.
Yeah,
And
we
then
of course, of course.
we will come out to the question, like Mr. Thiru said, how you can make the floating things to sink and then sinking things to float. So we will come
Okay.
out like this.
Okay, good, Mageswari.
Thank you.
Thank you. And somebody wrote here misconception that our pupils made. Okay, can anybody elaborate this? What does it mean? Who wrote this? Can you explain it? We go back to abstraction. What does abstraction stand for? Hello? Anybody wants to elaborate here? What does this mean?
I think, can I say something?
Sure, Dr. Nelson. Yeah.
I'm not sure in primary context, but in secondary, the misconception, dense and weight, jisim, mass. So children, or I mean students like to use is heavier than this.
Yeah.
The word dense and heavier are two different, what do you call that, skills, huh? So yeah, so students will tend to say that this is more heavy than this is heavier than that, hence this one sinks. So you can have the idea, so when you're marking and all that, so you see the word weight or you see the word mass, it's a different concept than the word dense. So you're looking to more dense, so the misconception is there.
Okay. So we try to use the computational thinking to make sure that the student will use the correct term in our lesson. So it's really hard to introduce the term density without even touching the word mass, for example, or volume. It's really hard to do this. So that's what Dr. Tiru said. We introduced the term density at the very early stage, year 3. But again, it is a challenge for us. Maybe like Geswari said, she used the example of liquid to show which liquid is denser or which object is less dense than water. Okay. Maybe anybody want to add about algorithm? Can we specify the step by step while doing the activities in 7.1 and 7.1.2? What does algorithm stand for? It's a step by step, right? So what can we put step by step here? Hello, anybody want to add? This is very easy.
Can I share?
Sure, Zaitun.
For this conversation, I think for my own opinion, for 5E, I will choose Dr. Tigu problem. For the first one, the problem why we use is it jacket when we ask them the question. So
Yeah, life jacket. Yeah.
life jacket, and then we let pupils explore with the activities for Cikgu Syafruddin, and then we made explanation. Teacher made explanation from the Dr. Tiwu and Dr. for before this, and then Dr. Tiwu and then the Nelson explanation, and then elaboration. I think the project is the project of Orange, Float and Sing, right, the Orange, and then I put the picture when my pupil use to add on some mango juice at their home from this elaboration project.
This picture.
This picture.
Okay.
Suddenly I have the picture, so I just put. So it fun. They choose their juice. I think oil, anything there. 8. So the evaluation, and then after that, just evaluation, simple evaluation. Evaluations based on pattern recognition. The water, float and sing. That's my opinion for base 5E. and then throughout the activities today. Thank you.
Okay, Zaitul. So you never mentioned like Dr. Nelson said, never mention the word weight or mass. We just pour the water and see which one is float, which one is sink.
Yes, because year 3, they have never think about mass anything, so we just tell and introduce them with the dance.
So if you want to make a very nice layer of, for example, Dr. Nelson said just now, if you want to make a very nice layer of different liquid, can we use algorithm to teach them how to pour the liquid? Is it possible?
Yes, it's possible.
Because it's going to be a step by step, right? So maybe we start with a denser liquid and move on gradually to a less dense liquid. Therefore, we can have a very nice layer of liquid.
Yes, and then
So that's
it can be extraction where they know the dance who come first and then up there, so they can see the connection of the dance from the materials.
so we're going to ask the students to do the algorithm then. Which liquid start first? Is it possible, right?
Yes.
Okay, good. Anybody else want to add?
Cikgu Zaitul, just want to ask just now your
Yes.
lesson, right? You said you start with the problem that Dr. Tiru asked. Is it what is the problem? Is it why does the jacket float? Is it that's the problem? Is it? What's the question?
What's the question? I think when we go to sea, when some lemas so the problem, jika ada seorang budak tu lemas, so what we can do? What to save the children?
Or what are the things that will help the person to float? Okay.
Yeah, I hear just to add what Zaitul was
Yeah,
saying
I understand now. Because that'll be more appropriate for the primary school students, because their level is just to identify what are the things that float and what are the things that sink. If the problem is asking why is that float, what is the safety jacket can help to float then you have to answer. We have to answer using the concept of density. But since I think primary level for us is just to identify what are the things that is float, what the things that sink. Am I right? For primary school level.
Yeah. So you put back us in perspective.
No need
Yeah,
to
good.
answer, no need to explain to them why does it float, why does it sink. Do we need to explain to them for
But
primary
if,
school level?
Dr. Loh, if they start asking, we have to we have to answer it. I think
they will ask like, how are we
Yeah.
going to answer this? My just now like some of you already asked, how are we going to explain the concept of density for primary school students? Actually, even I find it hard to explain to my son when I said density. Mass over volume. They cannot take it, but I don't know how to explain to younger children. Yeah, any ideas from teachers how to explain density for primary school level?
My own opinion, I have a problem like that because it's very intrinsic explicit title, but I just come up with the picture there, the water. So when we talk about float and sink, we just need a water, and then when the float is up and then sink down from the water. So that is just basic from year 3.
So
For
no
next,
need to explain density. No need for them.
from the activity book, also the question, also this one, dense water, flow and sink. So there is no explanation for more.
That's right. That's what I was trying to. I mean, of course, like for primary level, elementary level, this is
Can I add
this
something?
issue. Yeah.
Can I add in something?
Sure, sure. I mean,
Okay,
Sariza.
actually, in year 3, when we teach our pupils, we just focus on less than and more dense than water only, not
Only.
for the sink and flood, because sink and flood they learn in year 1. So we must focus on the based on the water actually. Sorry,
Okay.
my internet line not stable before. I right now it's okay. Sorry.
Okay, good for you. Okay, thank you, Sariza, for bring us back to our discussion. So, sink and float is in the year 1. Sink and float relative to water is in year 3.
Yes.
So
Yes.
we need to focus on the
Actually,
water.
Actually, for my pupils, for the last project in density, I asked them to show the different layer of water or liquid, the different layer of liquid. When you add something with, for example, sugar or salt, so it's become a different layer and become a bit different dense about the water. For I want to show you one project for my pupil. Can I?
Sure. Hold on a second. Let me
Okay, thank
unshare.
you. Wait, ah.
Okay. So tasty. So,
Okay, that's all.
yeah. So what do you find? What did you found from this activity? What does the students say?
Okay,
They
they say they what they conclude and fill in the table I give you. I give them, sorry. Again, they say when they add the water with sugar, the layer become below the layer become down, and then when they put the only the water, and then the water is light than the sugar liquid. Like that lah. The pupil say.
so did they use the word ketupatan density?
Then yeah, more dense, more and less dense. That's all.
Okay, so in
Because
other
I
words,
focus
you're
on the only a pure water.
okay.
Okay.
So they use the
So
word tumpat, density, dense.
Lebih tumpat daripada air, kurang tumpat daripada air. Itu
So
saja.
how do you explain the word tumpat for them? Dense. How do they define dense? Because a lot of students they will say like what Dr. Delson said, tumpat like heavy, macam berat. So we don't want to let them have that kind of misconception. So I am wondering how
For
we
my
explain this tumpat.
pupils actually I make an experiment in front when we teach it as a virtual. I use a visualizer, and then I make an experiment in front of them because I use Google Meet. So when the object is floods, it means the object are less dense water. I explain like that and the conclusion, and then the object, if the object is sink, the object are more dense water. So actually, my pupils is okay about that.
Okay.
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 Thank you
Like
for
here, may
sharing.
I
Thank
add
you.
to what?
Sure.
Yeah, may I add to what Salisa is trying to say? Like here, what they are trying, actually, what they are doing at the primary school level, they are introducing the word. They are just introducing the word, but of course, they have not gone into the details of the concept. When we talk about, see, the density, all right, there's concept like what Pondo was telling you, mass over volume and things like that. So with though that is the actual concept of density. But of course, when we impart these things in to primary school kids, We cannot, of course, go into the details of the concept itself, but we can, what we are doing is we are just introducing the term dense and less dense, more dense,
Yes.
less dense. That's all. That's all we are doing. That's. I think that's fine. Yeah. Right.
Okay, Dr. Tiro. Thank you, Saliza, for sharing.
Hello, Cik.
Thank you.
Welcome.
Hello, Cik Syafudin. Hello.
Hello. Okay.
Okay. Okay. Can
Hi,
I?
Riza.
Yeah.
Yes.
I'm the one that write down a sticky note about the misconceptions.
Okay.
Yeah. Sorry. Because
It's all right.
okay. Because I'm not teaching a level 1, but I'm teaching level 2. Okay, I'm teaching year 4, and then I'm doing the topic about the characteristic of materials. Then I ask them to do the simple activity, and then when they're about the when they put the plastic and all the all the material when they
Object.
yes, all the objects. Okay, and then when I asked them to conclude to make a conclusions, what they said that because the object are weight berat, they use the word berat, but they didn't use the word denser. Then I said, oh, they have learned in year 3, but they cannot. I mean, they cannot.
They are, in other words, they didn't get the concept.
Sorry,
Yes.
actually, year 3 is a new syllabus. Semakan.
Yeah,
Not
I know.
secondary. Yes.
I know. I know.
They don't know actually.
Yeah, I know. That's why in year 4 we need to we need to explain it again, because yeah, of course about Puan Saliza, Cikgu Saliza said that is a very new syllabus.
Yeah, semakan, right?
Semakan, yeah. That's why when they are in the year 4 we need to explain again about the density.
Density, yes.
But they, of course, they cannot absorb, but the concept, the density concept. Although they have made a experiment about that yeah.
So Puan Hariza, what you're saying is, although they have done the activities, in fact, they experience it in their real life, but they cannot really explain the concept right.
Yeah. Yes. They cannot explain the concept about density. They tends to use the word weight, berat.
Yes.
And then I explained, okay, how about balak? That's very big. And then when you put it in the sungai lah, dekat sungai, then you can see, then the balak will float. But when a small thing like stone will sink, then I ask them to think why. It's not about berat. It's not about berat.
Okay. Hi, Riza and Saliza. Thank you for the sharing. I just remember there's a one lesson plan that I shared to you when we say that the thing object that float have less things inside it. In our case, more kurang jisim lah. Tapi dia doesn't use the word because this is for primary students, they use the term things, THIN things. So object that have left things inside it can float. Object that have a lot of things inside it sink.
Yes.
So this is a challenging because this is very challenging because we're going to teach them the very complex concept, but we're not going to use the term atom, mass in our explanation. So it's very difficult. So somehow teachers have to be very creative when introducing this topic and see the level of our students. If the students can understand the word things in the object, maybe we can use the word things. So we have to be very creative. So this is a challenge to be a teacher. We need to find the right word.
Yes.
So when the student go to the year 4 teachers will blame the year 3 teachers for not introducing the.
I'm not blaming the teacher.
No, yeah, maybe we just maybe we make this wonder what happened during the year 3. That right? Maybe like that. Yeah. Okay, Dr. Tim, anything?
Yeah,
Saliza,
like what
can
you
you
say
stop
is,
sharing?
like what you said just now, all right? You say, okay, why does it sink? Because it has got more things in it, all right? Actually, when you say more things in it, the actual concept there is matter. Matter. A denser object has got more matter in it than a less dense object. Matter. The word there is matter, but matter is something that is very abstract and it is very difficult to be understood by children. So,
Again.
for now, if you use the word things, more things in it, that will be a more appropriate way to convey to them about this density concept. That's you. What you did was actually, or what you said was actually quite. Uh, easier for children to understand. Rather than, okay, let's say I were to go and tell them, okay, it is thinking because it has got more matter in it. Then the children will start blinking. They will not understand. Okay.
Okay,
Yeah.
thank you, Dr. Tiru. Is Maiza here? Maiza? Maiza, write down here. We can use the less air or bubble inside. If the object have less air or bubble inside it, it will be less denser. It will float. So I think Maiza is referring to the activity 7.1.3 just now when we use the air bubble to make the skinless orange float. Maybe we can say that, like Dr. Tiru said, maybe things that have more bubble or more air pocket in it, less dense. Things that have less air pocket or more things inside it, denser. So it will sink. So things that have more air inside it, like an air pocket or like a vessel or like a ship, there's a lot of vessel or like a submarine, it will float, for example. Okay, maybe we have to be creative in introducing this topic to the student. All right. Okay. Let's move on. Anybody else want to share?
Yeah, I would like to share something.
Sure.
I just want to say that it's all right, primary school teachers. It's okay if you don't get the concept across. It's still okay because we at Form 1, we will introduce the density, and after they know about the formulas and the numbers and the relativity with the numbers, they get the ideas much better.
Thank you, Dr. Les.
Yeah, because I think at the primary level is more macroscopic. That one they can see because for them they can't see how dense work, but they can see how weight because dia selalu timbang. They always see their weight. So you can see their weight. They can say I'm 56 kilos, 25 kilos. But the dense, there's a relative there. So it's more dense, less dense. It's just about relative. But when you introduce density 1.0, 0.9, 0.8, then they can understand that better. So at Form 1, they should be all right. Thank you very much.
That's why, Dr. Nelson, in Brunei, they didn't introduce the concept of density until secondary school.
Yes.
Because they don't want to confuse the students. So it's like a half baked. It's not a half baked. We introduce them the concept density, and then we just leave it like that. So there's no follow through in the syllabus.
Because density, the concept is a bit abstract compared to weight.
Yes.
Yeah.
Yeah.
So, and these students
So
are actually macroscopic, so they want to see things, then they can understand.
so
Thank
that's why the Brunei education doesn't want to introduce the term early in the primary school. Later on in the secondary school, then when they introduce the term, they start using all the formulas because they think the children are ready to get to use the formula in introducing the term density. For your information.
Yeah.
Okay.
So this comes back to policy research.
Go back to the research. At what age we can introduce the science concept? It's a very nice area. Okay, move on. Oh, nobody. There's a lot of here. Okay, never mind. I think we already covered about the density. Now we move on to the magnet. Okay. So the time is 4:45 already. All right. Hold on. Okay, I think we have a fair discussion about the density issues, okay, and how we're going to introduce the computational thinking in the activities. Hold on. Okay, now we go to the second activity, and just now we use density, and now we're going to use the magnet to uh, for magnet is in the year 1, okay, still under physical science. Okay, what we have here is 7.1.1. Student give example of magnet usage, but 7.1.2, we're going to introduce to them the all type of magnets. I'm not going to touch 7.1.1 and point 2. We're going to go through 7.1.3. We're going to make a generalization about the magnet action to everyday life object. Okay, what are the objects that can be attracted, can be pulled? What object can be repelled by the magnet? Okay, and then we on the 7.1.4, teachers had to make the student had to make the conclusion about the poles, which poles attract, what type of poles attract, and what type of combination of poles attract, and what type of combination of pole repel. Okay, and for 7.1.5, we're going to show them how to measure the strength of a magnet. I think so. You have the idea here. Okay, this is a loose translation. I'm using Google translation here. It's not translate very well. Okay. So okay, these are the London standard. For 7.1.3, mengiklak, we try to make a generalization from magnet action on various objects by performing activities. So we try to make generalizations. So in this activity, we're going to show them which object can be attracted and which object can are not attracted to magnet. Or in the simple term, which object stick to the magnet, which object does not stick to the magnet. So I think students have a lot of prior knowledge about this. And 7.1.4, we try to make a conclusion about the magnet pull and push between the poles, different poles, okay, and determine magnet strength on object by performing activities. Okay, let me show you the video. I'm not, because the time is limited, I'm not going to share you all the video. I'm going to choose one video that we can discuss together. Hold on. Once again. Okay, what I want you to do now is try to. This is not in the. This is like an extension phase. When we already teach them magnet can attract, magnet can pull, magnet can push, and we have already go through that. This is some kind of extension activities. Can you write down on the Jamboard what kind of computational thinking that we can apply in this activity? First, let's see the video first. Okay, I'm going to show you again the video. The Jamboard is the same link that I give you just now, but you have to turn on this on the last page, maybe on the page 8, for example. So for the Jamboard, you can write down on the last
Sir, I
page.
don't have the link, sir.
You don't have the link? Hold on a second.
Because my lines.
Okay, let me stop sharing first. I'm going to post back the link. Hold on. Okay, I already posted the link. Okay, let's see the video again. Okay, so what can you say about the video just now? Okay, please write down on the Jamboard so we can discuss it together because we only have like 8 minutes left here. Not enough time. Okay, please go to page 9. Sorry, page 7, and write down your comments, suggestion about the magnet video extend just now. So, what kind of decomposition or pattern recognition that you can introduce to them? Okay, I'll give you another minute. So what can you say when we change pole? What happened to the pins? Maybe somebody want to, yeah, like say that. Okay. How about the decomposition? How are you going to make the big problem into smaller part? Maybe you can write down maybe a magnet can attract metals, but in this case, metal drops. So can we do some decomposition here? So these are the composition thinking that we can, okay. Pins drop, although they are made from metal. So maybe they can, so maybe I don't know where to put this. Maybe in the abstraction or maybe on the decomposition. So these are the, so we want to make them think. Why the pins suddenly drop? Although they are made from metal. So I think this is going to make us think how to use the computational thinking to make the students think more. Okay, that's a good question. What makes the pins stick to each other? Okay, anybody want to? Okay, I like this. So this is a very nice question. What makes the pins stick to each other? Okay, this is a very maybe fall under. It can fall under decomposition. So the student have to uh, to to make the big problem into smaller. So they have to think back. So what made the uh, pin attract to magnet, for example? Okay, and the second question, what makes the pin drop, although they are made from metal? So this is the question that we can ask the students. Okay. Okay, I don't want to take any more time from you. Okay, anybody wants to make some comment here before we conclude our session today? Anybody wants to add? All right. Can I stop sharing now? Okay. Okay. Then thank you for being very active participants. So today we discuss about computational thinking and how we're going to put the computational thinking in our lesson plan, and we try to use the computational thinking in our day and our activities in class. So we go for a great length on the density issues, and uh, somehow we need to find the right word when we try to introduce the word density in our classroom. And for the second activity using the magnet, we don't have much time to elaborate, but hopefully you can try this at home and try to find the answer try to get the answer from your students, see what their thinking is. So maybe on that activity, we can sharpen their computational thinking skills, how to solve the problems. Any question before I conclude? Okay, before I end, I would like to say thank you for your time. Okay, you're very good participants, and I'm going to leave this to Bhavani. After you, Bhavani.
Okay, thank you, Mr. Sharfuddin. So we hope, ladies and gentlemen, you had a beneficial session today with our expert team. Okay, I heard many of you were sharing your knowledge and your experience in that what you have been doing. It's good to hear, even though I'm not so into teaching and learning. But it's really good to learn some of the things from all of you. So we are actually learning mutually from each other. So we thank all of you for your active participation, and we do hope that you will stay tuned with all our Wrexham events in future. So do like us on Facebook, especially to stay updated with all the events and programs. Yeah. Okay. So once again, now I see participants are 45 compared to 3 o'clock before. So I'd like to remind again, we will cross-check your attendance and the certificate will be issued for those who attended the first session on 3rd of September, the other day, as well as today, 1st October. So I will wait for the ICT team to give me the attendance list. We will cross-check your attendance of both days and I will send you personally the evaluation link, maybe on Monday. Okay, so once we have given that, I really do hope to hear from you on your feedback. Then the e-certificate will be issued upon hearing from you, your responses. Thank you so much. So stay tuned with us. Stay safe, most importantly. Okay.
Do you want
I
to
think
take
many of us are going back to work.
Bhavani, can we take a photo?
Yeah, sure. Yeah, I forgot about it. Okay. Please on your camera. Is ICT someone around there? Diana, Fiza. Okay, right. Thank you. Okay, is everyone ready? All right. Thank you, Dana. Thank you.
Okay, thank you, everybody.
Bye-bye. Thanks, everyone.
Thanks for your time. Thank you.
Thank you.
Thank you, everyone.
Is it the attendant link? It's there?
Do you want to answer?